So some small commands left here, not small but some commands left here. That is format also does not require that much. I explained these things yesterday. Closed deepened corner, break corner, chamfer, belt table is completed, pattern is not required. This is stamps. Then next thing is bend, rebend. Okay, fine. See here, guys. See here, okay, in sheet metal. Like yesterday, the commands, whatever I explained in the previous class, that is important only, very important in sheet metal. Here, two more commands are there. It is also very important. That is unbend and rebend. See, usually these punches we are not using in sheet metal designs. Okay, okay. But still, I will explain that one once. I will create one base sheet. Definitely, we require this one. So rectangle, center rectangle I am taking here. Finish. Okay. Okay, now see here I am getting one flange of this edge. Here some height, for example. Okay. This is my component now. The first one is dimple here. Dimple is a kind of stamp here. So here we required one curve. So based on that curve only it will create the dimple here. For example, I am taking here curve. Right now I don't have any curve, so we have to create curve. So select any face for creating the curve here. Then you will enter to the sketcher environment. There you can able to create the curve. I'm creating one rectangle, for example. Finish sketch. Now see here the dimple curve has been created. How much depth you require you can able to specify here. Okay, how much how much height you want you can able to specify here. Apart from that one, if you want to give any side angle, means if you want to make this thing taper, okay, if you want to make this thing taper, you can able to make taper also by giving some angle like 5 degrees like that. Now see here it is making somewhat taper here. If you see from the top side, you can able to see the difference. See, it is I'm giving the angle to be like 20 degrees. See, it is making taper like that. So like that we can able to give here this remaining values will remain constant here. Rounding, if you want to give, you can able to give like punch radius, tie radius, means this radius which you are seeing here now, this fillets. So those radius you have to specify here. Corner radius, how much you want? Corner radius I have given 0.1. And die radius I am giving 0.1 and punch radius I am giving like 0.1. If you want to change this one, you can change here like this, like that. So like that we can keep these values how much we require. Okay, that is my first option, that is dimple. So here inside you want, outside you want, means see here if you see from the bottom side you can able to see something here. See, this is my cross section now. If you take outside, means it will come the sketch will come outside here. If you go for inside, the sketch will come inside here. So like that we can able to see material outside, material inside. Like that also we can able to do here. Okay, but here I am getting very big radiuses, so I am giving 0.05 here, 5 here. So like that these values we can able to give how much angle you want. So after giving these parameters we can able to see the punch here on our face. This one is first punch option. The next one is lower. For lower also we required some cross section here. I am giving one lower, I am creating here. For example, I am creating one rectangle here also. Finish sketch. See here width must be less than half the section depth. Okay, it's very big. I'm giving 0.1 only for example. Okay. Less than the half of the section. Depth, this one. I'm changing the width value. That actually the depth value, whatever we are seeing here now, it should be less than the half of the cross section. Okay, less than the cross section length. So this value we have. Wait a second, Akhil. Yeah. Now here, Akhil. Here we have two types of things are there. Now see here. Here it is creating this bands, or we can say lowers. Why it's creating like a display? I think we have to create an open. So I'm going for the lower option. So there's this space. For example, I'm creating one line here. Finish sketch. Wait a second, actually. I'm creating. Yeah. Now see here. So lower means here we have to create an open profile. With the help of close profile also we can able to do. Okay. Now what we have to do means depth. How much depth you require here? That much you can able to specify. Means it should be like the length value is there now. So based on the length only it will take the value. So 0.4 it is taking. If I am giving more than 0.4 it is not getting showing that error there. That depth must be less than or equal to minimum material thickness. So like that it is saying there. So I am giving 0.4 only. So width, how much you required? That much width we can able to create here. Like this. Okay. Inside you want, outside, like bottom side, top side, where you want here, and this side you want, that side you want. So which side you require, you can choose this option. Now see here, this is the first kind of lands. Lower here, the first one is lands here, the other one is formed, like that. So these things we can able to create with the help of this lower option. These things here, these lowers are somewhat useful in sheet metal designs, because here also we will use in our company. See here, have you seen the trains windows? So there you can find these kind of shapes. So these things we can able to do with the help of lowers. Okay, with the help of lowers we can able to create these things. Okay, this is lower option. The next one we can find here is draw cutout. So go for drawn cutout, select this face for creating the sketch here. For example, I am creating one rectangle, finish. Now see here, it will create like that. It is same like this one only, dimple, but in dimple it will not remove this bottom face, but here in drawn cutout it will remove this bottom face. The remaining the things will remain same only, like roundings and side angles we can able to specify how much we want here. Remaining thing will remain same, only the things it is changing here is there it will create the bottom face, here it will not get any bottom face. That is my drawn cutout. The next option we can find here is bead. Bead we required here also, we required one sketch. Here it should be an open sketch only, like I am creating one line, finish sketch. So like that we can create the beads here. Okay, what is the depth you want, what is the radius you want, form you want, length you want, or punched, how you want, you can create that. I want only form only for example, and give the parameter. Circular you want, U shape you want. If you give U shape, you can make like this. If you want the V shape, you can give V shape also, like that. Okay, so like that we can create the different shapes and with different end conditions. Form you want, length you want, punch you want, taper you want. So like that we can able to create our beads. The next one is cassette. Next one is cassette. Cassettes will create on the bends area. For example, I have this bend now. At that location, cassette will create here. Select this face. Plane you want to select. I am selecting, for example, this plane. And here we have some body which looks coming like that. First dimple I will delete here. Okay, close. Now go for the option cassette on this face, plane as this one. Now see it's creating now. Why it's not creating previously means here we have some feature like dimple feature is there, due to which it is not creating. Now we can able to create here. Automatic profile you want, manually you can able to create here, like curves, lines we can able to create here. For example, if you go for user defined here, it is asking you to select the curve to create the sketch. I am creating here. What shape you require you can give. For example, I want like this. Finish. So the same thing it will create here also. Then width we have to specify, side angle we have to specify, punch radius we have to specify, and die radius we have to specify. So like that, cassettes we can able to create here. Side 1, side 2, or symmetric. Square shape you want, round you want. So based on your requirement you can able to see here. Say it is a round shape. If you want square shape, it will come square shape also. Okay, that is my cassette option. Okay, that is cassette. The last option is there, that is solid punch. For this one we require some cross sections. Okay. Press M1 to enter into the modeling area. Because solid punch we require solid commit, like part body we required here. So go for M. Okay. I am creating one sketch on this face. Okay, and I am creating one rectangle thing. Close, finish sketch, extrude this one, the reverse direction. Okay, make it a little bit taper here. 3 degrees. Okay, now I am making one hole in this one. this geometry. Finish. Okay. Okay. Now see here, for this thing we have here something like that. Whole depth I am giving some a little bit bigger only. Okay. I have this hole. Why it is not making hole here, but this on the sheet means this is a separate geometry. This is a separate sheet here, so there is no relation between these two things. That's the reason it is not cutting to this geometry. Okay. Now go over sheet metal, Control Shift M for sheet metal. Now go for solid punch. Okay. Punch we have to select. I'm letting, for example, this is my target face is this one. Tool body is this one. Click OK. Now see here the punch has been created. Okay. How you created that thing now? The same kind of punch it will create in this location. Understand, guys? How to do this one? Nothing is that just we have to create one solid body. Then come to sheet metal here, and that solid body must be intersected with this sheet. Then it takes solid punch. On which face you want that? I want the top face. Then which is your tool body, the body which you created in part modeling, that is your tool body. And click OK. So automatically your punch has been created. Okay, so these are the different punches we are creating. These are the different punches we are creating here. Yesterday I already explained normal cutout pattern, you already know. These commands you already know. Why? Because we have discussed this in part modeling. Now the next option is bend and rebend. Unbend and rebend is very important thing. Suppose for example I want one hole at this location. Okay, which is the hole is lying on this face as well as on this face. So in that case directly we can't able to make hole here like that. Like that hole we can't able to make here. So in that case what we have to do means, first of all we have to do unbend. So if it is asking me which one you want to make at the stationary face, for example this is my stationary face, then bend face, I am pretending this is my bend face. Now see here it has been unbended here. See here the bend portion will remain like that only. Here is unbend. So doing unbend means the bending portion will not change, just it will make like a flat sheet here. Now whatever feature you want you can able to create. For example I want normal cutout on this face and I am creating a rectangular cutout like this. Finish sketch. Okay, normal cutout has been done. Then after performing this work, again you have to rebend that. So go for rebend, select this feature. Now see here, the hole is sharing both the things. So like that. So this is a very important, what we can say, very important thing which we are using currently in sheet metal designs. Okay, first of all we have to do unbend this one. Okay, then make a cutout, then rebend. That is the work we have to do on this. Okay, suppose for example if you are taking sheet layer only by taking this cutout means it will not make a proper plan. So that's the reason it's very important unbend rebend. Not only for this one, so many operations you will do here while doing unbend and rebend. Okay, unbend means the bend whatever it will be, it will make like a flat. Rebend means the whatever unbend you have done, it will reverse that operation. Okay, that is unbend, rebend. Resize bend radius. If you want to resize your bend radius, you can resize here. It is saying the design intent or deform or cutout feature may have changed after resize bend radius. Here we have one cutout due to we are changing the pen radius here, it will get deformed here. It is showing some warning here. So if you change, let's see what deformation we can able to see there. So we are not seeing any deformation here. It will be remain like that. Okay, like that we can able to do resizing our bends. How much you want? Initially is 0.1. Right now I made this is 0.2. Now I want to make 0.3. So what is the whatever the bend size you required, you can able to keep bend radius. Okay. The next option you can find bend resize bend angle. For example, here we have the bend here. So if you want to change the angle of this bend, we can able to make. What is the stationary face you want? I want this should be a stationary face, and this my bend. Now how much angle you want? 90 is there. I don't want 90. I want 45 degree, for example. Okay, so like that we can able to keep the bend angle. Okay, like that we can keep the resize our bend angles. For example, if you already created the flange, that flange I want to change the angle, means you can do like that. Here also we can able to change by double clicking on that one. With the help of this one also we can able to do it. Okay. Then resize neutral factor is not that much required option. Why? Because it is only used when we are using the proper materials. So in that case we can able to see the differences. Now you can't able to see anything, right? Because the value is very less here, and this neutral factor usually is a formula value. It is a standard value actually. So based on the material capability, this value will get decided. So if you change also, you can't see anything. That is your reside will factor, neutral factor. The last option you can find here is flat solid, flat pattern, export flat pattern. This is very important thing here, flat patterns. See here in CAD also I explained you regarding the flat pattern. Here also flat pattern is very important thing. What is the use of flat pattern means? For example, see here I required a sheet. That sheet usually what we will do, we will cut in CNC machines. See laser machines are there. So in that one we will cut this sheet metal sheets. So for that one, for CNC we required the codings. So those codings we will do with the help of DXF files. Like in NX only directly we can able to DXF file. That file we import to that file we will use to generate the G code and codes. So for that reason, what we will do is we will create the flat. Flat pattern means it will not show any bendings to you. Just it will show the bending lines for that one in the drafting area. Completed is look like a single sheet in flat pattern. All the dimensions we have for that. So that is very important. So in that case, what you have to do is you have to go for, first of all, you have to go for flat solid. What is the stationary phase? This is my stationary phase. Okay, this is my stationary phase. Click. Now see here, the flat solid has been created. Okay, flat solid has been created. The next thing is flat pattern. Go for flat pattern. Stationary phase is this one. Click. Now what happened here? Right now you can't see anything here, but we can, when you go for the model views, here you can see flat pattern view is there. So just double click on that one. Now you can see that flat pattern view. So in drafting it will show like this. Okay, in drafting it will show like this. That is my flat pattern. Understand this one? Nothing is there. Now go for flat pattern. Select the stationary phase, which one you want to make as a stationary phase. For example, this is my stationary phase. Click OK. That's it. So what happened saying that flat pattern feature is created in the flat pattern view. The name of that view is flat pattern number 1. Place the view to see the flat pattern. Okay. Now see the flat pattern has been created. If you want to see this flat pattern, you can have to go for model views. Double click on this flat pattern. Now you can able to see the flat pattern. Flat solid also required. Flat pattern also required here. Okay. First of all, we have to create the flat pattern. Then we have to go for flat solid. Go for flat solid. Select this one. Now see here, flat solid also there, flat pattern also there. Okay, like that we can able to create the things. export flat pattern means the flat pattern whatever you create. If you want to export this one means like DXF file, I already said that DXF file, that thing we can able to do. DXF file, with the help of this DXF file only, we will create the G codes and codes for CNC machine. Okay. Understand?
Yes, sir.
Yes, sir. This is the sheet metal design. If you have any doubts, you can ask.
No, sir.
No doubts. And one more command is left where I forgot to tell you command. Okay. For pressing M, analyze one modeling area. Creating one sketch. Okay. Creating one center rectangle. Finish. Extrude. This one. Now go for sheet metal by pressing Ctrl Shift N. Here we can find sheet metal from suppose for example if you have any body here, that body I want to convert to a sheet metal means you can go for sheet metal from solid. Select the interface, the bottom face I'm setting as interface and select bend edges. I want bends to be like this edge. Sheet metal, surface, this one, this one, this one. Right side, okay. Now see here, it has been like that we can able to convert our solid body to a sheet metal body. Okay. Then also you can find convert to sheet metal wizard. Select the edge. Convert to sheet metal base versus this one. Also wrong. Actually, the thing is, whenever we are working on this thing, like for using the license version, then it works properly. Like this is a single command only we can able to convert our solid body to a sheet metal body just by clicking on it. Yeah, like anything here. Okay, so like that we can able to create sheet metal. Any doubt guys in this one?
No, sir.